Hello and welcome to video number 3 on our series of looking for the most accurate clock on Earth, which is based on the Foucault pendulum, which is a clock I've heard about, never seen, but I believe it exists. Now during that, I believe I found one, or possibly something that would actually be so close to it, it would almost do the job. It's made by a company called Novatech in USA. It's basically a beautifully made, very accurate Foucault pendulum that is mounted in a glass cabinet, and its height is 57 inches or 1440 millimeters high. It looks like it does everything the Foucault pendulum should do, and it possibly, I haven't contacted the company to investigate this because I have to actually understand, I have to remain isolated from anyone. I have to do this independently. But it may be time-stamped. I'm not quite sure on that, but being time-stamped, what that means is, according to your latitude, wherever you are, this thing will take a certain time to go around. And the next day, it should take the exact same time. And the next day, the exact same time, which would make it effectively represent the Foucault pendulum clock. Now it cost $1,861.52 US, so if you just want to muck around with any more pendulums and just go straight out there and buy something straight off the shelf, there it is. It looks to be very well made. The fact that it's also 1400 millimeters, which is about here, half the height of mine, means we can put to rest this argument of whether a Foucault pendulum needs a minimum of 12 metres in length to work. Here we have a commercially made, off-the-shelf product, 1440 millimetres high, that actually does the job. Therefore, the 12 metre minimum length, let's just cross that one off. Also, number 4, before we go into our experiment, remember I always said, should the bob turn? Should it twist? So, no, bob should never twist. It should never turn. So, we can actually put that one to rest as well. So, let's tick that box. The bob must not turn. That one's done, and that one's done. Two things off our list. Let's get on to our experiment now, just give you a brief what happened. As you know, I put my 2 universal joints on the pendulum, the glass pendulum, and to eliminate vectors and isolate vectors. And what I found was, when I phased my universal joints, you might see these 2 little red dots here, they were in phase, that means the links were in phase. They became virtually a constant velocity joint. The pendulum, the bob twisted. Well, as soon as I lined it up, it went twisted around, which meant that I have a problem with my bob. Okay. So I have to redesign the bob. Big setback. It took me a lot to do that bob. That took many hours and mucking around to get that thing. And I thought I had it accurate with, 0.1 of a millimetre run out. But anyway, in order to phase the bob so its launch index indicators in phase, I had to twist the thing and line up the fudge the universal joint, and something strange happened. When I was doing that, I discovered something and I thought, wow, gee, okay, someone's missed something really important, right? And I'll show you that now, and I won't tell you what it is, and hopefully you'll be able to guess it between now and my next video, but I'll just give you a little clue. before we set the experiment up. So let's just go to that now, and I'll just show you that little clue, and hopefully before the next video you might be able to discover what I also discovered. Something that clockmakers, quite embarrassing, you've all missed this, so alright, here we go. Alright, here's our clue. That now some of you fellas are pretty smart, so I won't give you too much. Remember my little gauge? This bit of wire that wobbles, and it's used to measure fly poo. One fly poo measurement, this one. So remember, I can just turn the plane pendulum, which is this pendulum that virtually spins on nothing. Remember that? Now admittedly it weighs 486 grams compared to 100 grams, but I've got quite a bit of leverage just on this edge. What happens now when I do this bob? You watch this. I don't even touch it, I just barely touch it, and this thing moves. Okay, that's all you get. No more clues. So here we're at the top, and you'll notice that the universal joint axles are 90 degrees to that aluminium strip, which is our true angle for launch. Alright, let's go down to the bottom. So down here at the bob end you can see that the launch indicator index is out of phase with the axles on the universal joint clearly. Alright, so there's probably 15 degrees, something like that, shift to get this thing to go straight. Okay, let's go to the launch. With our bob perfectly still, we'll do our launch. Now, as I said before, this will go in a probably anti-clockwise direction, which is probably to do with the bob in balance, but we want to see that elliptical orbit. Just reposition myself around to see that. Travelling exactly almost north-south at this stage. Now already the bob's becoming unstable, the pendulum becoming unstable, because it can't do what it wants to do, because those universal joints are locked, so it can't do its thing and try and straighten itself out, because both vectors are isolated. You can start to see that elliptical orbit starting to grow. I'll just go over to the line now, on the wall. Here's our mark on the wall. Clearly that line is going Yeah, clearly you can see that little line moving more on the right hand side than the left, which indicates that it's going anti-clockwise. But coming back to the front of it, wobbling now in an extremely elliptical orbit. Now, somehow I believe that a perfect Foucault pendulum, if the Earth was revolving, it should make a very straight line with a slight ellipse. Nothing like this in a few minutes. This has been going, what, 5 minutes, and it's gone crazy. So this is the sort of errors I would got early in my pendulums when I had very big imbalances. However, if the smart people are watching, here's another clue there I gave away that I didn't expect I'd give that away, but anyway, you should be able to pick it. So now you've got 2 clues. Alright, I think we've got enough. This is no use. This is just no watching this deteriorate any further. Clearly it's getting some sort of weird elliptical orbit there going. Alright, I think that's enough, and we'll see you in the next video. Thanks for watching.